Bismillahirrahmanirrahim. Assalamu alaikum. This is presentation number one of Principles of Chemistry 1. Resource person is Dr. Hammad Majeed. I am Aqsa Bano from DSBT batch 10 holding ID 20010231019. I am here to present the topic of my presentation, that is vanadium. Here are some content of my presentation: history, definition, properties, isotopes, reactions, reactivity, uses, key properties, occurrence, abundance in nature. First of all, we discuss the history of vanadium. The discovery of vanadium happened twice. Vanadium was discovered by Andres Manuel del Rio, a Spanish chemist, in 1801. Dio sent samples of vanadium and a letter describing his methods to the Institut de France in Paris for analysis and confirmation. Unfortunately for Rio, his letter was lost in a shipwreck, and the Institute only received his samples, which contained a brief note describing how much this new element, which Rio had named erythronium, resembled chromium. Rio withdrew his claim when he received a letter from Paris disputing his discovery. Vanadium was rediscovered by Niels Gabriel Säfström, a Swedish chemist, in 1830 while analyzing samples of iron from a mine in Sweden. Vanadium was discovered isolated by Sir Henry Enfield Roscoe, an English chemist, in 1867 by combining vanadium trichloride with hydrogen gas. Today, vanadium is primarily obtained from the minerals vanadinite and carnotite by heating crushed ore in the presence of carbon and chlorine to produce vanadium trichloride. The vanadium trichloride is then heated with magnesium in an argon atmosphere. Next one is definition of vanadium. What is vanadium? Vanadium is a rare element occurring in certain minerals and obtained as a light gray powder with a silvery luster or as a ductile metal, used as an ingredient of steel to toughen it and increase its shock resistance. Vanadium is a compound that occurs in nature as a white to gray metal and is often found as crystals. Pure vanadium has no smell. It usually combines with other elements such as oxygen, sodium, sulfur, or chloride. Vanadium and vanadium compounds can be found in Earth's crust and in rocks, some iron ores, and crude petroleum deposits. So next one is, here are some basic information about vanadium. Its atomic number, symbol, name, electronic configuration, melting point, boiling point, atomic weight, density, and its crystal structure. Next one is properties of vanadium. Here are some properties of vanadium. Vanadium atomic and orbital properties. In the atomic and orbital properties of vanadium, there are atomic number, number of electrons, number of protons, mass number, number of neutrons, shell structure, electron configuration, valence electrons, oxidation state, atomic term, symbol, quantum numbers. Its atomic number is 23, number of electrons 23, number of protons 23, mass number 51, number of neutrons 28, shell structure 28112, electron configuration Ar3d34s2, valence electron 3d34s2, oxidation state -3, -1, 1, 2, 3, 4, 5, and in the end atomic term symbol 4f3 by 2. Next one is chemical properties. In the chemical properties of vanadium, there are CAS number, thermal neutron cross-section, electrode potential, ionic radius, electronegativity, X-ray absorption, electrochemical equivalent, and its quantities are there. Next. Next one is physical properties. Physical properties, density, its melting point, in its boiling point, and their quantities are available in both metric and imperial system. Next one is mechanical properties. In the mechanical properties of vanadium, there are Young's modulus, shear modulus, Poisson's ratios, Mohs hardness, and their quantities is also available in metric and imperial system. Young's modulus metric 1 to 8 GPa, shear modulus metric in metric 47 GPa, Poisson's ratio in metric 0.37, Mohs hardness is in metric is 7, and in imperial Young's modulus is 18465 KSI, shear modulus in imperial 6816 KSI, Poisson's ratio in imperial 0.37, and Mohs hardness in imperial is 7. Next one is thermal properties. Thermal properties of vanadium. Thermal expansion coefficient at the rate 25 degree centigrade or 68 to 77 degree Fahrenheit. Thermal conductivity and their quantities are also available in both metric and imperial system, as you see. Next one is isotopes. Vanadium has two naturally occurring isotopes, 50V with an atomic mass of 49.9472 AMU and 51V with an atomic mass of 50.9440 AMU. The atomic weight of vanadium is 50.9415. Next, there are some reactions of vanadium with other compounds. Reaction of vanadium with air. Vanadium metal reacts with excess oxygen upon heating to form vanadium oxide. When prepared in this way, V2O5 is sometimes contaminated by other vanadium oxides, and the reactions of vanadium with air is given below. Reaction of vanadium with halogens. Vanadium react with fluorine when heated, forming vanadium fluoride, and the reaction of vanadium with halogens is given below, as you see. Reaction of vanadium with sulfide. V5 is not precipitates bisulfide in 0.4 mole HCl, but is reduced to V4 under alkaline conditions. And here are some reactions of vanadium with sulfide. Next one is reactivity. Reactivity of vanadium. Vanadium is moderately reactive. It does not react with oxygen in the air at room temperatures, nor does it dissolve in water. It does not react with some acids such as hydrochloric or cold sulfuric acid, but it does become more reactive with hot acids such as hot sulfuric and nitric acids. Next one is uses of vanadium. Small amounts of vanadium are added to steel to make it stronger. Surgical instrument, tools, axles, bicycles, frames, crankshafts, gears, and jet engines are made from this strong steel. Vanadium pentoxide is used as a catalyst to make sulfuric acid. Sulfuric acid is one of the most important chemicals for industry. Vanadium pentoxide is also used to make maleic anhydride and some ceramics. In the future, a compound of vanadium may be used in lithium batteries as an anode. It could also be used in rechargeable batteries. Vanadate and other compound of vanadium protect steel from rust and corrosion. Vanadium dioxide is used to make glass coatings which block infrared radiation. Fake jewelry can be made out of vanadium oxide. The inner structure of a nuclear fusion reactor can be used to capture neutrons, making the nuclear reaction much safer. Superconducting magnets can be made out of vanadium. Some bacteria and other organisms use a vanadium compound to fix nitrogen. These are the uses of vanadium. And next one is key properties of vanadium. Pure vanadium is bright white in appearance, soft, ductile, has good structural strength, possesses good corrosion resistance to alkalis, sulfuric acid, hydrochloric acid, and salt water. It oxides readily at room temperature at temperatures greater than 660 degrees centigrade, has a low fission neutron cross section. Next one, occurrence of vanadium. Vanadium in native form is rare in nature. It is the 20th most abundant element in the earth crust. It is present in crude oil, coal, oil shale, sedimentary rock, and tar sands deposits. Vanadium is detected spectroscopically in sunlight and in the light from other stars. Vanadium in the form of their compounds exists in nature. It is mined mostly in South Africa, Northwest China, and Eastern Russia. And the next one is abundance in nature. Abundance in universe 1E206, abundance in sun 4E207, abundance in meteorites 6.1E205, abundance in Earth's crust 0.0000019, abundance in oceans 1.5 into 10 to the minus 2 minus 7%, abundance in humans 3 into 10 to 6%. And here are some references of my presentation. That's all about my topic. Thank you so much and Allah Hafiz.